reason I'm saying this is because the first thing that we're going to chat about is terminology. And while I'm not saying it's not important, it is. It's very, very rare that I'm ever going to ask you for a definition or that you are ever going to be asked for a definition. It does sometimes happen, but honestly, what we want you to be able to do is apply all of this knowledge to questions, right? So you're just sitting and listening. There'll be time for questions as we go along, but right now you're sitting and you're listening. So as we start to move into this geometry section, there are certain words that we need to be comfortable with. So firstly, a point. Now guys, a point is represented by a dot, and we label or we name that point with a capital letter. So very importantly, when you see capital letters on diagrams, on geometric images, what you need to realize is that that capital letter is the label for a point. And you're going to see later on, these points eventually become vertices of shapes. So a point is a dot, we label it with a capital letter. And so if we had a dot, it'll come eventually, there we go. So if we just had a dot and an A next to that dot, that is point A. Right, as we sort of increase in the complexity of our geometric structures, we can join 2 points, calling it a line segment. And importantly, guys, because you've got 2 points that you've joined, each of those points have a label. So there's point A, there's point B. And what that means is then you've got a label for the line. This would now be line AB. It is the line joining point A to point B. So line segments join 2 points. We can label those line segments using the letters of the points that the line is joining. So that's points, those are line segments. As we go in geometry, what you're going to see that we often work with are angles and angle sizes. Now, points and line segments form the foundation of the creation of an angle. Panic? So first thing is that angles have arms. So arms are the 2 lines that meet at a common point. We call that point a vertex, forming an angle. So the arms of an angle are the 2 line segments that essentially join or that create an angle. So if we look at this diagram down at the bottom, we've got arm AC and arm AB creating the angle in between them. So arms create angles. Like I say, these 2 arms will meet at a common vertex. So the point where the arms meet is a common vertex. And that specific point will be where we start to label our angle, which we'll chat about in a second. An angle then is the amount of space that exists between our 2 arms. So again, if we look at our diagram down below, arm AC, arm AB, all coming from a common vertex A. The amount of space between those arms is called our angle. And like I say, this is the foundation of the geometry that we are going to essentially focus on in maths. Angles and the line segments that create them. Now, like I said, let me get my words right. There's lots of different ways that we can label angles and name angles. And we're going to chat about that next. Right now, what I want you to do is take a screenshot of these 5 terms, and then we'll go on to how we label them. Jason, we are going to do cointerior angles, just not yet, but in this course, we will be doing them. If you want to know specifically, I think it is going to be lesson 4, I think, but it's in this course. We are going to do them. It's in this course, just not today. So guys, take a screenshot. I'm hoping we don't have any questions at this point. There will be time for questions, but remember, you can put your questions in the chat and we will answer them. Alrighty. So guys, like I say, angles are going to be your bread and butter in geometry. You are going to work with angles until you don't want to work with angles anymore, unless you love geometry, which is awesome. I enjoy geometry. But what's really important is that because we are going to be working with angles, and often what we're going to be doing with angles is we are going to be finding the size of an angle, so determining the size of an angle, we need to be able to label angles. Now, there are 4 different ways that we can label angles, and please listen to my words very carefully. You do not use all 4 ways. The way you label an angle depends on the information given to you. Okay, so sometimes in a diagram, there's no labels on any of your arms, but there's a variable for an angle. You'll use the variable. Sometimes there's numbers on the angle. You can use the numbers. We're going to go through all of these ways in a second. But the way you label an angle depends very much on the information you have been given. And so this is why we need to be very, very mindful of the questions and reading the questions and what information we have been given. So in primary school, most of you would have learned how to label angles in the first way that I've got here. Now, that's not to say we don't use this anymore. Sometimes we do, but it's not one of the common ways we label angles. So in primary school, you would use like a sideways slanted L, and then you'd put a letter. So here you can see I've highlighted in blue angle A. It is the angle created at point A. There's nothing wrong with that. But what we want to do is we want to move away from the slanted L, and we start using an A with like a little hat on it. That little hat on top of the angle or on top of the letter means angle. So we're talking about angle A. Now, again, we don't often use this because you're going to see as we go on that often there's more than one angle at a vertex or at a point, and we need to be very specific when we label our angles. Sometimes we do just use the letter, that's fine, but this isn't one we use commonly. The ones we use mostly are the last 3. All right, so if we look at the second way to label an angle, the second way is using 3 letters. Again, see that there's a hat on top of A. That's telling you that the angle is at vertex A. So if we go to vertex A, we can see that we've got arm AB, we've got arm AC, there's my common vertex A, and there's the angle created between the 2 at A. Now, guys, those letters in this labeling essentially follow the arms. So if we start on the right-hand side, we go from point B to A. A is where I've got my angle. And then we go from A to C. B, A, C. So this is why my 3 letters that I've got here for my label follow those arms. I follow my arm BA up to AC. I put a hat on the A because that is where my angle is. So very importantly, grade 8, when you're labeling like this, the order of the other 2 points doesn't matter. So you could have, if you wanted to, have labeled this C, A, B. But what you need to notice is that the angle, so the position of the angle, that is always in the middle. So you can put the other 2 letters in any order you want, but the vertex where the angle is, that is always in the middle. And you can see that in both versions. So this one, the 3-letter way of labeling an angle, is just following the arms. B to A to C, that creates my angle. You put a hat on top of where the angle is, and that must always be in the middle. All right, the third way of labeling angles, and this is if we give it to you on the diagram. Okay, so this must be on the diagram. Sometimes what we do to make life easier is we put these little numbers on a diagram. Now, guys, these numbers are useful because if we look at this diagram nice and carefully, we can see we've got this vertex A where the angle BAC is created. But at this very same vertex, I also have a second angle, DAC. So I've got a second angle here. Remember I said right at the start that we often don't use this first one anymore because often there's multiple angles at a point. This is an example of that. At point A, I have got 2 angles. I've got the angle BAC or CAB, and I've got the angle DAC or CAD. It doesn't really matter. Remember, the A just has to be in the middle. Now, mathematicians are quite lazy, and so writing out 3 letters is a bit of a job. And so sometimes what we do is we put the numbers on our diagram. So rather than trying to label this first angle, so let's just get this first angle BAC, we just call it A1. BAC is still perfectly fine. There is nothing wrong with saying BAC, but angle A1 is a lot easier to work with. In the same way that our second angle that we have here, DAC, so DAC, we could just call angle A2 because there's a little number 2 here that tells me it's the second angle at A. So when we've got these numbers on the diagram, we can just say that. Okay, Joshua, you can't say ABC. Remember, the point where the angle is must be the angle in the middle. So the A has to be in the middle. You either say BAC or CAB, but A has to be in the middle. Okay, because that's the point where the angle is. So again, guys, if there's little numbers on your diagram, use them. So much easier than the 3-letter one. And it's still a label for an angle. The fourth one, and this is what we'll use quite a bit, particularly in grade 8 and grade 9 geometry, is where I actually just give you a variable. So what I'm saying is you can see that there's no labels for any of my arms here. I'm saying that this little angle down here is just angle X, and the angle above it is angle Y. There's no need for the letters. I don't have to put the 3 letters. Got X, I've got Y, those are my angles. Again, this will be only if this is given on your diagram. We can't just add things that aren't on a diagram to a diagram. It must be there. But if you've got X and Y labeling angles, just use X and Y. There's no need to try and overcomplicate it with letters. Use X, use Y, that's it. All right, so I'm going to stop here, take your screenshots. If anyone has any questions, now is the time to raise your hand and ask me. Otherwise, we're going to start to look at the crux of geometry, which is basically starting to look at different characteristics of angles and straight lines and how we can now apply them to different questions. So any questions, you can raise your hand. Otherwise, we're going to move on. We actually might take a brain break first, but let's see. Right, Joshua, there should be a pop-up to unmute yourself. There we go.
Okay. So, ma'am, I can't use A, B, or C. I have to put A in the middle.
Yes, so you can use A, B, and C, but it has to be in the middle. So if we go here and we follow, I start at B, I go to A, and then I go, and now it's got a line. Let's try that again. And also, let's not be orange. Right. Start at A, I go to B, and then I go to C. So I do that, B, A, C, and I put the hat on A because A is the angle. I could have gone the other way as well if I wanted to. So I could have gone from C to A to B, so C, A, B. But again, A is in the middle, that's where the angle is.
Okay, ma'am, I understand. Yes,
okay,
ma'am.
Good, well done. Okay, so guys, that's really important. If you're going to label it with the 3 letters, where the angle is, that has to be the middle letter. Okay, we can't have like the angle randomly somewhere. It must be in the middle. And then the other 2 letters, it doesn't matter what order you put them in, just put them there. But this is also why having variables or the numbers is actually quite useful, because then you don't have to stress about the order. But we can only do that, unfortunately, if it's given to us. All right, so guys, I actually think let's take a brain break before we start doing the actual geometry, because we've done the terminology. Awesome. We'll take a little break before we do the geometry of it all. All right, so here's our brain break for the day. You know how this works. I want an answer to this question. Maybe I need to work it out as well. First person to get the answer in the chat will explain it for us. Let's see how we go.
Our talk, guys, of today. Just read it in your hearts and laugh while you're busy stretching.
I don't know how good my maths is tonight, but we live in hope. Someone has already gotten the answer, but because I was slow, I'm going to give everyone a second to get there. But I do know who it is, and I will call on you. But let's give everyone a chance. So guys, remember what we're trying to do? We're trying to find the value of that last equation there. I'll scroll up again now for you to take a screenshot. Don't stress. I will go back up in a second. Let's just finish this off and then I will go back up for you.
That was so fast. The person that got it
Yeah.
did it really fast.
Right, Teto, you are the one. So if
Ooh,
you want to raise your
Well done
hand,
today.
you can explain this to us. There we go.
Hello, ma'am.
Hi, how are you?
I'm fine, thanks, and you?
I'm okay, thanks. Okay, you can explain it for us.
Yeah.
Yeah.
So for the first one, it doesn't, this whole thing, it wasn't like those double things, and there's two of them. So it was just 30 divided by 3, which gave me 10. So the cat is 10.
Perfect.
Then for the second one, I did inverse operations. So
Good.
22 plus 10 equals 32. Then because there were two pigs, I said 32 divided by 2, which left me with the pig being 16.
Good.
Then for the last one, since I had already known that the pig was 16, I said 16 minus 11, that would be the horse. So I ended up with
Okay.
the horse being 5.
Good.
So then the final thing I had to solve was 10 plus 16 plus 5, which gave me 31.
Perfect, Teto. Well done. Excellence. Okay, so guys, really importantly, I hope you all listen to Teto's explanation there. Inverse operations. This is an equation. That's all we're doing. We're solving the equation. Cameron Teto is very good at them. I don't want him to try. Oh, English. We don't want retirement, but we I hope that everyone is trying. Okay. I also held off there. I didn't let Teto speak too quickly. So try. Like, this is practice of solving equations. The joke, why are circles so hot? Because they're 360 degrees. Guys, this is what we've been speaking about today. A whole circle, if you go all the way around it, is 360 degrees. Now, if you think about 360 degrees in terms of temperature, that is very, very, very hot. I feel like I've now ruined the punchline of the joke, but that is the joke. Alrighty. Okay, there was a question from someone to just go back to take a screenshot. I'm going to scroll back up there now to take screenshots, but now we're going to also start with like the really fun geometry. And this is essentially applying relationships between straight lines and angles in order to solve for unknown angles. Okay, so if you missed out on the screenshot, there it is. If you hadn't had a stretch, have one. I said funny last night, now my back's sore. I feel like I'm getting very old. Why are lower numbers harder than higher numbers? I don't even know what that means. Clearly, it's a Monday. Alrighty, guys. Okay, I hope you all got your screenshots. So, like I said, this is the fun part of geometry. This is now where we can take relationships between angles and lines and we can start applying them to solve for unknowns. Now, what you're going to see in geometry, especially if you plan on doing this all the way up until matric, is you are going to have basically like a list of reasons or of characteristics that you're going to have to learn and you're going to have to apply. So we're going to start with the first one tonight, and essentially what this course and the next course is going to be is us looking at all of the geometric reasons that you need to know. So the question earlier of co-interior angles, corresponding, all of those fun things, they're coming up. They're part of our reasons. But the first one we're going to look at is angles round a point. Now that's quite self-explanatory. It is all angles around a single point. Those angles add up to 360 degrees. Okay, so if we look at our little diagram here, if you imagine all of these arms drawn in, creating multiple different angles, but all around the central point, what you see is that if you add them all up, actually what you're getting is a circle. And we know that in a circle, hence the joke, in a circle, we have got 360 degrees. And so what that means is if we add up all of the angles, we must get 360 degrees. Okay, now guys, what's really, really important in geometry is this statement down at the bottom here. Whenever we make a statement that involves the angles, or generally it's the angles in our diagram, you have to give a reason. You don't have a choice, you have to do it, right? Now, you'll see throughout all of these lessons, these little things that I put in the blocks, these are the reasons that we have to give. So we will make a statement and we have to give a reason. Right, so the reasons are important because it tells your marker, or it tells your teacher, or it tells yourself why you are doing what you are doing. Why are you adding the angles and getting 360 degrees? There's my reason. Just from like a marks point of view, especially in grade 8 and grade 9, the way we allocate marks is we say you get a mark for your statement, a mark for your reason. So if that's the case, if you didn't write down a single reason and your whole test, let's say, is on geometry, you will lose 50% of your marks because half of your marks are going to be for reasons. Now that's a very, very silly way to lose marks. So that's the first thing. The second thing, second reason why, actually it's probably the third reason, I know I can't count tonight. The next reason of why the reason is so important is because as you move up in maths, so as you start to get to, I've lost my mind, grade 10, 11, and grade 12, especially if you want to do maths, what they start doing is they start sort of making an assumption that you know these reasons and you can apply them. And so they start combining those two marks. So you get 1 mark for your statement and your reason. So what that means is if you don't put a reason, you can't get the statement mark. You lose all of your marks instead of just 1 mark. And so it is so, so important, grade 8s, that you do write down your reasons. If you don't, you are messing yourself around. You're just going to lose marks unnecessarily. Okay, Joshua, I'm not too sure what the 50 is for, unless I've missed something, but I hope we're all on the same page here. Okay, so grade 8, what I really want from you guys now is we're going to look at an example, but I want you to listen, because the way, or me working through this example is going to explain to you how to set up your answers. And again, this is really important in geometry because if we don't set it up properly, we're not giving those reasons and so on, we're going to lose marks, and we don't want to do that. So if we have a look at our very first example here, guys, what I would do, especially at this sort of point in life where we're sort of starting to get into geometry, I would set up my page as follows. I would separate my page into 2 halves, and each half is going to contain different bits of information. Now, remember I said we want to make a statement. So 1 half will involve my statement, the other, my reason. We have to give both. And yes, Teto, unfortunately, as much as they're a pain, but look at that statement there, guys. Lost 30% due to nothing but lack of reasons. Imagine being able to get 80, 90, 100, even 60%, but you lose 30% because you forgot your reasons. So silly. So you have to give the reasons. You just have to, it's part of life now. What I would suggest, guys, is you have a separate piece of paper, and every time we do a new reason, you make a little reason list for yourself, and you've got one sheet of paper that you can always refer back to with all of your reasons. So Joshua, yes, you always have to give a reason. It's non-negotiable. You have to do it. No choice in the matter. Okay, so guys, let's look at the diagram. What we see that we have here is we've got this angle X. You don't have to label it, but this is an acute angle. This is not important. We're just refreshing some information in our brains. But what we also see that we've been given is the angle outside of X, which we know is a reflex angle. Again, I'm not asking you to label the angles. We're just doing a bit. Do you remember acute and reflex? Not important. Just remember that they exist. What we also see is that if I put the 310 and the X together, what I'm getting is a circle. So if I go all the way around with my acute and my reflex angle, I get a full or complete circle. And we know that that contains 360 degrees. I've already accounted for 310 degrees. I need to figure out the missing angle size. I need to work out X. So your instructions for a question like this would be something along the lines of determine the size of X. And sometimes we're nice and we say, giving all reasons. We give you a little hint that there should be reasons. Right, so looking at our diagram, we can sort of see what we need to do. We are now going to make our first statement. We know that X plus 310 degrees must give us 360. I'm making a statement about how I'm going to start solving for X. But because I've given a statement, exactly as Joshua said, I have to give a reason. You have no choice in the matter. You have to do it. Our reason here, and we go back up to what I said our reason was, this is just what we write down, angles round a point. Now, grade 8s, you can abbreviate angles to the little sideways L with an S. That means angles around, and you can abbreviate point to PT. Mathematicians are quite lazy. If we don't have to write something out, we don't. So don't stress about the full words or full sentences. That's horrible handwriting, but we're just gonna leave it. If you don't want to split your page in half like I've done, just put your reasons in a bracket. But if you've got your page split in half, got your statement, you've got your reason. So if you think of it, you've made a statement that we're adding two angles together to get 360. The reason I am doing this is because angles round a point add up to 360. So statement, reason, right? Little side note. Some of you learn different reasons at school. That's fine. So some people say angles of a revolution. Absolutely fine. Okay, it essentially means the same thing. So you are welcome to use the reasons you have learned at school, as long as it is a reason you have learned at school and not one that you're just making up. But either you are using my reasons or the reasons you've learned at school. Now, the reason I'm being quite strict about this is because for whatever reason, okay, when you get to matric, they're very strict about the reasons that you give. So if you just make up a reason, unfortunately, they're not going to give you the marks. So you're either using your teacher's reasons or my reasons. Okay. So we've got our statement. Remember, the question says determine the size of X. So we actually need to go and answer the question. Otherwise, this was all a pointless exercise. So now what we have is an equation that we're going to solve. So inverse operations tells me that I must subtract 310 degrees on both sides. So 360 minus 310. And so what I have is that X is equal to 50 degrees. Now, grade 8s, because this is an equation, you can go check yourself. So if you now replace this X with 50, double check that when you add 50 and 310, you do get 360. We do. So we've done our answer correctly. So this is quite a basic example to start off with, but the reason we started off with this was A, to ease into it, and B, so that you can see exactly how to set up your work. Again, your reasons might look a bit different. So if you're using that angles of a revolution, no problems whatsoever. But again, my reasons or your teacher's reasons, please don't just make up reasons. Okay, unfortunately, they are quite strict with reasons, and so there's only certain ones that they accept when it comes to marking. Alrighty. Any questions at this point, grade 8s? You can raise your hand if you do have any questions. Otherwise, we're going to have a look at another one. Ortile, yes, you do have to put degrees. So guys, much like with measurement, you always have to put your units of measurement, so centimeters, meters, whatever. With angles, angles have a unit. That unit is degrees. So we do have to put the degrees there. Okay, Joshua?
So, ma'am, the reason must always be like that, or can it be different?
So we will, oh, English. Let me try that sentence again. We will learn lots of different reasons. Right now, we've only learned about this first reason, angles round a point. So this lesson, we're only going to use this reason. But as we start to learn more and more reasons, you can then apply the reasons as appropriate.
Okay, ma'am.
Okay. So guys, that's a really good point. As we start to learn more and more reasons, you're going to be able to apply them differently as you move along. So right now, we've only done one reason. So our reasons will only be angles around a point. But as we do more and more, depending on the question, you will have different reasons for different answers. Okay, if you don't put the degree sign, you won't lose marks, but it also depends on the teacher. So personally, I would take off a mark, if I'm being like completely honest, because it is a unit of measurement and because we learn that you have to give your units if they are. So I personally would take a mark off of a student's work. I wouldn't take it off every single question that they left it off. I would do it once. That's how we do it. But personally, I would take off a mark. So it depends on your teacher. Maybe your teacher is much nicer than me. That's cool. But do try and remember it. Alrighty. Omfa, don't know what that means. We're not there yet, so just hang on. Right, so grade 8, let's have a look at the second one over here. I hope you all took screenshots, otherwise I'll come back later. My first question to you, and quickly put it in the chat for me, what does the square mean? So in the chat, what does the square mean? Good, guys, well done. All right, so it means it's a right angle or 90 degrees. So the reason I'm asking you this is because sometimes, and especially in geometry, what we do is we just put the square. We don't write the 90 degrees like we did for the 60 and the 70. We just put the square and we expect you to know that that means 90 degrees. So if you didn't know that, hopefully you do. And every time you see that square on your diagram, it means it's a 90-degree angle. Cool. So let's have a look at what else we've been given. Again, we see we've got a common vertex where all of these other angles are around. And so if I were to add up all 4 of those angles, I see that I'm forming a circle, and so 360 degrees. Okay, so again, we're going to set up our answer. Remember, statement, reason. Try to do a straight line. Thank heavens, computers can do it for you. Statement, reason, and you have to give your reasons, guys. Like I said, unfortunately, you don't get a choice. So our statement here is that if we take x plus 90 plus 60 plus 70, we know we must get 360 degrees. So I set up that equation, and that is my initial statement to this question. My reason for this? Well, because I'm working with angles around a point. Right. Now, guys, what I want you to notice is that 90, 60, and 70 are all actually like terms. So rather than trying to work with 4 different terms, let's just add them together, make our lives so much easier. So 90 plus 60 plus 70 is 220. I'm going to say that with confidence. I'm pretty sure it's 220 is equal to 360 degrees. We're solving our equation. So what we're going to do now is we are going to subtract 220. Remember, inverse operations. And now I'm darting all of my mathematical abilities. It is 220. So 360 minus 220 gives me an angle X of 140 degrees. Right, so a couple things. Firstly, do you notice that once I've given my reason, I don't have to keep writing it down? All of these subsequent steps are follow-ons from my initial statement. I don't have to rewrite my reason for every single step. As long as the steps all form part of the same working out, the reason at the start, and then that's it. Second thing I want you to notice, if I go back up to how we label angles, remember the fourth way to label an angle was using variables. In both of these questions, we have used a variable to label an angle. And we could do that because on the diagram, we were given X. So we have worked out the size of angle X. We used our inverse operations and we solved for that unknown. Alrighty, so take your screenshots. If anyone has any questions, now's the time to raise your hand. Otherwise, I'm going to give you 1 or 2 for you guys to try, and then we'll see where we're at. Joshua?
So when the x equals 140, the plus always has to change into a minus, or the minus always has to change into a plus. It's opposite. Jesus.
Yes, sorry. Yes. So because if we look at step 2, this was plus 220. Because I'm bringing it to join the 360, the sign has to change to a negative. Yes, it's inverse operations.
Okay, ma'am.
Okay. So guys, if you're struggling with the inverse operation thing, go back and watch the equations videos. It's solving an equation, but Joshua summed it up nicely there. If it was positive, becomes negative on the other side of our equation. Right, I hope you've got screenshots of those two. Okay, so I want you to try, let's start with question 3. I want you to try question 3 by yourselves. So in the chat, what I want to see is your answer and your reason. So you don't have to show me all of the working out, but I want to see what answer you get. And I want you to put down what reason you used. Again, just we have only learned one reason. So there's really only one reason you should be writing down. Answer and reason in the chat. Remember, guys, you can check yourselves. If you substitute back into the diagram, if you add all the angles up, does it give you what it's supposed to give you? Remember, I want to see both your answer and your reason. Good, grade 8s. I'm going to give you another minute. So those of you just finishing off. Again, guys, you are welcome to abbreviate point to PT, but you can also write it out if you want. Not a problem either way. But obviously, remember, you want to try and save as much time as possible, which is why we do allow for abbreviations and such in our reasons. Because some of the reasons you're going to see, especially when you move into like grade 10 and grade 11 maths, some of the reasons are like a full sentence. And so if we can abbreviate, we abbreviate where we can. Okay, good. So we're all getting it. Well done. Our statement is that x plus 140 plus 110 must give us 360. The reason we're making that statement is angles around a point. Right, we can solve our equation again. 140 and 110 are like terms, so let's just add them. That gives me x plus 250 degrees equals 360. Like we've just discussed, inverse operations means that I've got x is equal to 360 minus 250. And so wonderful, guys, x is equal to 110 degrees. Again, substitute it back into a diagram and make sure that when you add 110, 110, and 140, you do get 360 degrees. Good. Okay, so now what I want you to try is question 4. Remember the instructions said, determine the value of x. So not of 2x, determine the value of x. I want you to try by yourselves. I'm leaving 3 up there just in case you still need it for whatever reason. But I want you to try question 4 here and determine the value of x. Remember to give your statement and to give your reason. Lisa, honestly, if you said angles round a point rather than around, it's fine. I use angles round a point, not around. I'm just making an effort here tonight to say around. Round is fine. Like I say, we're not super strict with the English. It gets the point across. Yes, sorry guys, you're trying question 4. So yes, you please need to put your answers on the chat along with your reason. Okay, guys, there seems to be a screen issue. Please remember that advice that Yolanda's given you before to pin and unpin and all of those things, but I am resharing. You should be able to see, yeah, you should be able to see the screen now, but Yolanda has sent that message, so please do try that as well. It is absolutely fine to get decimals or fractions in geometry. There's no problem with that. So don't be scared if you are getting fractions or decimals. Guys, because it is a measurement, you're measuring the size of an angle. Generally, measurements we do, don't get my words. Generally, measurements we do write as a decimal rather than a fraction. We won't mark you wrong either way, but generally any sort of measurement we write as a decimal. Glad to see we're checking. I'm going to give you 1 more minute, guys, and then I'm going to go through it. Alrighty, so I'm actually going to start with what Joshua has actually just posted in the chat. There is our statement. We know that we've got angles all around a central point. So 2x plus 2x plus 70 degrees must give me 360. Why? Well, because angles around or round really doesn't matter a point. Okay. Teto, it's all right. We all have them. It's okay. No problems. Right. So now we've made our statement. We've given our reason. We can now work this out. Now, guys, 2x and x are like terms. 2x plus 2x is 4x plus 70 degrees is equal to 360. We're going to subtract 70 on both sides. So 4x is equal to 360 minus 70. And so 4x is equal to 290 degrees. Now remember the instruction said solve for x. So if we want to solve for x here, what we need to do is we need to divide both sides by 4. Because remember, we want to get x alone. So we take 290, we divide that by 4, and that gives us that fraction answer that a lot of you were writing down of 145 over 2. Now, again, guys, we like to try and write our answers as a decimal. It's a measurement. Decimals are preferable. So 145 divided by 2 is actually then an angle size of 72,5 degrees. All right, so again, because it's a unit of measurement or because an angle is a measurement, we try and write it as a decimal. It's not wrong if you leave it as a fraction. It's not the end of the world, but convention just says decimals. Right, so you'll see the poll is up. Please make sure you fill it in before you go anywhere. I'll obviously leave my screen here in case you're taking screenshots. There are a couple minutes left, so if anyone has any last minute questions, you can raise your hand and you can ask. Otherwise, guys, make sure that poll is filled in, please. Cameron?
Ma'am, I wanted to ask a question. When it's 4x, don't you divide it by 290 and then, because I got 72,2.
Okay, so remember what we divide by is based on what the coefficient to x is. So because the coefficient of x is 4, I want to get rid of it. So I have to divide by 4. So this would be 290 divided by 4. Cameron, you still there?
Yes.
Does that make sense?
Yes, ma'am.
Okay, good. Joshua.
So, man, why for question 4 did we divide?
Because remember, I'm solving for x. So right now, what I have at this step is 4x. I don't want 4x, I just want x. So I have to get rid of that 4.
Oh,
Okay,
oh, okay.
good.
Okay, ma'am.
Ma'am, is it okay if I first wrote 4x plus 70? Yes, absolutely. Like, honestly, if you can simplify first, that is winner. I'm just really drawing it out right now. But if you can say 4x equals, even if you said 4x equals 290, not the end of the world, but yes, 4x plus 70 equals 360, perfect. No problem there whatsoever.